Hello everyone. In this video, we will be talking about how we measure beta. In the last video, we have seen that to calculate weighted average cost of capital, we use CAPM, capital asset pricing model, where the required rate of return is a function of the risk-free rate and market risk premium and the beta of an individual stock. Now, we previously have learned that beta measures market risk, which actually measures the sensitiveness of individual stock returns to the market movement. That means for a given change in the market return, how much individual stock return changes. Now, we can estimate beta by running a regression. I will show you shortly. Before that, look at this diagram where we have market return in the horizontal axis and stock return, which is Dow, in the vertical axis. So each dot, if you look at these dots, each dots basically indicate the individual stock return for a corresponding market return. Okay, individual stock return for a corresponding market return. Individual stock return for a corresponding market return. And this is a regression line, which is the estimated relationship between the market return and individual stock return. And the slope of this regression line will be beta, which will indicate that for a given change in market return, how much the individual stock return will change. And if we run a regression, between these two, we find that beta is 2.34. In week 5, we have learned that beta greater than 1 indicates that the firm's riskiness is higher than the average risk of the portfolio or average market risk. So you can see that this is more riskier than the market portfolio. This regression was ran for a period between November 2004 to October 29, and this is for November 2009 to October 2014. And if you look at beta, for the same market return and stock return, beta has been changed from 2.34 to 1.65, indicating that beta is not static. Beta changes over time, right? So if we use historical beta to forecast a future beta, we may not be very accurate. Now this is a very similar example for Microsoft, but you can see that Microsoft beta is 0.95 for this period and 0.98 for this period. So although the beta between these two periods slightly changes, but you would definitely agree that Microsoft is less riskier compared to Dow, because Dow's beta is much higher compared to that of Microsoft. And this is for Campbell Soup, which is, you can see that beta is 0.35, where here beta is 0.39. And once again, although beta slightly increases, but you would agree that Campbell Soup is much less riskier than the Microsoft, and definitely compared to Dow. So among these three companies, if we compare the beta, I mean the market risk, we see that Campbell Soup is the least risky. It has the lowest market risk, whereas the Dow is the most riskier one. That means it has the highest market risk. Okay. Now we will look at another statistic, which is R square. You can see R square here is 0.44, 0.60, and here is 0.35, 0.37, and here is 0.10 and 0.08. So what does this R square indicate? If you know about this R square, it's called coefficient of determination. In a regression, R square basically indicates that the proportion of the variation in the independent variable, which is, say, Campbell Soup in this example, the proportion of variation in individual stock is explained by the market return. And you can see that only a small portion, for example, 10% of the variation of Campbell Soup comes from the market movement. And 35% of the variation in Microsoft comes from the market. And 44% of the Dow Jones movement comes from the market. So you understand that only a small portion of the variation of individual stock returns comes from the overall market factor. So majority of the variation of individual stock return is attributed to firm specific variables, which is called the unsystematic risk factors or diversifiable risk factors we discussed in week 5. Now, I will quickly show you how we can run a regression to get the beta of a stock and also how we generate a figure like this. Here we have an example where we have an individual stock return, which is the BHP return, and this is the market return, which is a return from ASX 200. And the data ranges from February 1999 to 2013. So to calculate a beta, first of all, we need to find out excess return. Excess return means individual stock returns minus risk-free rate. So we call it excess return because this is the return generated by this company in excess of the risk-free rate. And we get the excess market return. So market return minus the risk-free rate. Okay. So now we get excess return for individual stock and for the market. Now to run a regression, we will go to data and data analysis. If you go to data analysis, you find a regression here, right? So we have regression. Now we need to put the Y range and X range. Y range is the dependent variable and X range is the independent variable. And dependent variable is a BHP return because we want to see that how BHP return is affected by market return. So market return is an individual return here. Market return is an independent variable which have an impact on BHP. And BHP is a dependent variable because it depends on market return. So first of all, we select BHP return, and then for X range we select the market return, right? And we check this box, line fit plots, and if we click, then we get this. I am making it larger. Okay, so you can see here, so this is our regression line, and these are the individual dots, as I already said, that each dot represents an individual stock return for a corresponding market return. Okay, and if you look at this regression result, you see that this is what we are basically interested about. So this is actually the beta of the stock, beta of BHP, which is 1.17. So you see that BHP is slightly more riskier than the average risk portfolio or the overall market. And you can see that R square is 40%, which indicates that 40% of the variation of BHP comes from the market and remaining 60% is attributed to the firm specific variables. This is a further example where we have beta for different companies here, and you see that, for example, Canadian Pacific has a beta of 1.34, CSX has a beta of 1.34, Kansas City Southern 1.27, Union Pacific 0.98, and industry portfolio is 1.24. And you understand that we calculate this beta from historical return, so that is subject to some error, and this is the level of a standard error we have, which is actually indicating the range within which our actual beta may fall. For example, this is when a standard error is 0.19 and our beta is beta or historical data is 1.34. So if we add this 0.19 with 1.34 and deduct, we get a range, the lowest range and highest range, within which our future beta will lie, which is the expected beta. Okay. So this is the end of our discussion on how we estimate beta, and in the next video we will be talking about asset and cash flow beta. Thank you very much.